Hello, I'm Mr. McBrien. This is TEJ20, Arduino 3, analog output from a digital device. So yesterday we talked about accessing user input from the serial monitor, as well as pushing output out to the serial monitor to communicate with the user. Today we're going to talk about something cryptically called pulse width modulation, and again make use of the keyboard and the serial monitor for communication with the user. Okay, a quick review of power. When we talk about power, I'd invite you to think again about your definition of it. When it comes to cars, we talk about horsepower, which the units are different from a circuit, but the idea is really no different. Power is energy per unit time. More power means more energy per second. We usually talk about joules per second or watts. And really, we're just simply talking about how much energy is expended in a given time. More power equals more energy consumed, or another way of looking at it is more output. And we use the calculation again in the circuit. Power is voltage times current. Now, we haven't really talked that much about controlling power. In a car, we control it by pushing down the accelerator, of course, to generate more power output. Things are not nearly so simple when we want to talk about an Arduino. Having said that, there are lots of applications for that idea. So, in terms of circuits, we know about dimmer switches for controlling how bright lights are. We have motors that we want to go at a given speed, for example in robots. And other applications such as temperature controls. Now, many devices don't support a linear response to voltage. What do I mean by that? Well, I'll qualify it a bit over the coming slides, but what I can say is we don't have an easy way to control power output. And anyway, even if we could use simple voltage to control power output, unfortunately the Arduino doesn't support the idea of changing voltages in an analog manner. In other words, we can't simply choose what voltage to output from the Arduino. There are very limited choices available to us. So the question becomes then, how do we do things like run a motor at 1/3 power? How do we control speed? How do we control power? So first off, let's discuss zeros and ones again. Quick reminder, Ohm's Law. Current is voltage divided by resistance. So the higher the voltage we dial in, the higher the current. And when we know that then that current can be controlled by voltage for a perfect resistor, in theory we could do things like change the power of motors and LEDs, etc., just by simply changing the voltage. And in practice this can be complicated. Often things like motors, they don't behave like perfect resistors. It's all or nothing, or 0 or 1. So the motor will only turn if a certain voltage is applied, for example. Similarly, LEDs can have similar kinds of behavior, where they can't behave as a perfect resistor. And so we can't have good control over power in that way. And instead of using voltage to try to control these things, Instead, we use a trick. So if we look at an LED, we could theoretically get at something like power by changing the amount of voltage we put through an LED. And we've already seen this when we changed the resistances. But it really isn't that easy to control. And so we don't do it that way. Instead, we simulate the analog output that we see here of 23% brightness versus 100% brightness, for example. We simulate it using pulse width modulation. So what is PWM? Well, it really isn't all that complicated. What we can do is, instead of changing the voltage, we can drop the voltage to 0. We wait a very brief period of time and then bring it back up to on, or in our case 5 volts. So since in our Arduino we typically have the output of 5 volts, we can't use our digital pins to directly supply 2.5 volts. But what we can do is pulse the output on and off very quickly to achieve something like 2.5 volts. So it isn't 2.5 volts at any given time, but it looks like it is. And the reason why is because the pulsing is so quick that it's invisible to the naked eye. And so if we dig into this a little deeper, we can see that our output voltage, our effective output voltage, is just our on time divided by the cycle time times our 5 volts, our nominal voltage. So in theory, what's being produced by the Arduino is 0 volts on at 5 volts for 75% of the time, off for 25% of the time, on for 75% of the time, and this is effectively 3/4 power, or 75% of 5 volts, or 3.75 volts. To achieve the 2.5 volts we discussed in the previous slide, all we have to do is just run 50% duty cycle. So 50% on, 50% off, and effectively we see the results of 2.5 volts. So this kind of approach can work for motors, can work for LEDs, can work for a large number of applications. And the Arduino manufacturers certainly anticipated this kind of necessity. So we have 6 different pins that have built-in PWM circuits. 3, 5, 6, 9, 10, and 11 all support this idea. And the command to turn them on and use PWM is really very simple. It's just analog write, the pin number, and the value, anything between 0 and 255. So 255 then would be 100%, or 5 volts. 128 being half of 256 is essentially a 50% duty cycle and stands in pretty well for 2.5 volts. Similarly, 256 over 4 gives us a 25% duty cycle. So really there isn't much more to discuss here. We can try out PWM pretty easily. What I'd like you to do is write a sketch to use this to change the brightness of an LED at pin 9. And you can just modify the code and see the difference in the LED. If you want to, use several LEDs and you can compare them between the different pins. Don't forget your resistor when you're doing this. And yeah, go ahead and build this sketch and then unpause the movie when you're finished. yes, I did have an extension. If you want to, you can set up a loop that goes from bright to dim. Instead of doing the pulse like we did in our previous activity, you can dim and brighten the LED in a loop. Okay, welcome back. So hopefully you had fun setting up your LED and experimenting with PWM. Now what I'd like you to do next is incorporate what we learned yesterday with keyboard inputs. So modify your program from the first activity to control the intensity of the LED based on user input. And you can use the serial parse integer method to read numeric inputs from the keyboard and use that to have the LED be anywhere from 100% intensity at 9 to off at 0. Okay, to summarize, we have a situation where we have a very powerful little widget that's not really designed for analog output. An Arduino is a very digital beast. And anyway, many devices don't work well with analog voltages regardless. Having said that, we can do a pretty good job of controlling the power to various devices using fast switching on and off. And this is totally transparent to us. We simply, it looks like we're dialing in the power by using this pulse width modulation concept. Okay, for your homework, please go ahead and upload your sketches to Google Classroom, and feel free to continue to experiment with the extensions or with any of your inventions around what we've learned so far. Thanks very much. Have a great day.